data we have. This was having 300 data points, and we tried to explore with it. Every time what we are doing, okay, we have seen this in this map, which is what our model selection sort of thing. And we have ensemble classifiers, both here, ensemble regressors. Okay, so this ensemble has a lot of inbuilt methods already, and one of the methods, one of the model is random forest classifier. There are other models that you can explore. This is what we are exploring. Okay, now tell me this: why do we need all of this data frame and stuff? Why are we doing this? What's the need of doing this? Can't we just directly predict? Why do we need to create it into data frame, see, uh, get value counts, get data type? Why do we need this? Answer it fast. Answer, guys. It's not a rocket science question. Basic question. Why are we using data frames? Why are we deducing all of this like head value counts? Why? It's a basic question. You have attended my class. You should know why we are doing it. Okay, we won't move forward unless you guys answer me. No, this is about Narendra Modi. This is not about deep learning. What did I say? What is written in this notebook? Scikit-learn. What is this class about? Recap. If you attended Monday class, you know we are doing a recap of scikit-learn. Classify data for more convenient to do on work on that. Pandas data frame is a structure that contain. I didn't ask you the definition of pandas data frame. I am asking the whys now. I want to know why you are using. Why do I need to use it here? Murli Sovani, um, that is the correct answer. Exploratory analysis. The precise answer is, what are we doing here? We are basically doing data analysis, which involves these three process: data evaluation features. We are doing data analysis. Why do we need to do data analysis? Answer me. We won't move forward unless you guys answer me today. Why do we need to do data analysis? To gather insights on data. Yes, but you just defined what is data analysis. I'm asking why. Why do you need to gather insights on data? No answer is right or wrong. It's okay if you guys give me wrong answer, but it's not okay if you guys don't even answer me anything. To do more operations on data, no, wrong. To make predictions, maybe, but wrong. Enabling them to make decisions, no. To train a model, no. To train model to make predictions, that's the end goal. Why are we doing it right now? To get better output of no. Okay, it's sort of right to take further actions, but like there has to be a precision to get correct. To clean the data, no. Provides a deeper understanding of processes, behaviors, and trends, no. Predict unknown values, no. You guys are giving me generic definition or like Google like definition. But when we were doing this class, there are significant things that we do to make significant stuffs. Predict unknown values, no. I mean, data analysis, not predicting value. You are gathering information. Someone said it already. You are gathering information. Okay. But why are you gathering those information? Why? Why do you need all these information? That's the question. Why do you need data analysis? Why you need to analyze this data? Why? To make predictions is our end goal. So why? To get more clarity on the data, this is like, yes, but that's the same thing as like to do data analysis. That is why we are doing. But why? Okay, Murli, you answered it correctly. For selecting a model. Unless and until we actually analyze this data, we won't be able to understand this data, and eventually we won't be able to select the right model. Step 2, choose the right model. We need to understand this data, right? Is it a classification data? Is it a multi-classification data? Is it a clustering data? Is it a regression type data? What type of data it is? What is the length of this data? What is the amount of this data? What type of data types are in this data? Is it quantifiable data? It is non-quantifiable data. Is it like vague, or is does this data has missing values, or it does not have missing values? What does this data has that you have? Is it structured? Is it unstructured? Does it compose of text, or it composes of images, or it composes of something else? You need to understand that to choose the right model. Okay, that is why we are doing data analysis. Today, Civil Lakshmi, we are basically reading about history of Narendra Modi, Prime Minister of India. Okay. If you are confused, you can read here. Cool. So we chose sklearn ensemble random forest classifier. Now, why we chose this? Why did we choose this? Okay. So I remember in this notebook, I already had this diagram on which we go back again. This one, right? So first of all, how do we choose right algorithm? We did this data analysis, right? Now we can have different types of problem. It can be a classification problem, clustering problem, regression problem, unsupervised problem, and so on and so forth. It can have different types of problems. This is the chart that has been provided by scikit-learn, right? It is already there also in their website. It is also there in this notebook. Okay. Now you start with it, you go here, then you say, okay, do you have more than 50 samples or you have less than 50 samples? If you have less than 50 samples, it is saying that you need more data. If you have more than 50 samples, then basically you define what type of data it is. That is why you did this data analysis, because you want to know what type of data it is. So is your data having some type of category, or it has some type of quantity? Okay. What are you trying to predict? Are you trying to predict a category, or you are trying to predict a quantity? Okay. What is a category? When do you say something has a category? Okay, quickly answer me. When do you say something has a category? When do you say some data has a category? Numeric means category. That's what you're saying. No, it's wrong. When it has a target label. It's right, but I need a bit broader answer or a much more direct answer. Discrete values is very cryptic when it can be categorized. Yeah, but that is what I'm asking. When can it be categorized? When are categorization the data as true or false and yes or no? That's one form of categorization, but that's not always the categorization. Okay. Category is something when you can basically say that you have finite number of options and the output that you are expecting will be from that finite number of options. For example, if you are having three types of car, it can be a sedan, it can be a SUV, or it can be a sports car. So this is like three types of categories of car. Or when you are saying a car has different number of doors, like it can be a two-door car, it can be a three-door car, it can be a four-door car. Okay. Or you are saying how many types of human breeds are there. For example, there are whites. Okay. I mean, it might sound odd when I'm saying breed, but breed is in like ethnicity, okay, in terms of human. Okay. So how many types of ethnicity is there? Indian, it can be blacks, it can be whites. Okay. So there are it can be Chinese, Asian sort of. So Asian ethnicity. So there are so many different types of ethnicity, but it is still finite number of ethnicity and it can be categorized into. So this is what a category means. So when you see a category which has finite number of selections and from which you need to select something, that is what category. What is a quantity? Quantity is something that you can't categorize but can be quantified. For example, price of potato or vegetables or something like that. You want to, you can only set a numbers on it, right? It can be like 25 rupees, 26 rupees, 20, can be any number, variable. It is very variable, it can be any number. Okay. For example, if you want to say age of all living organisms, then it is extremely wide. It is so wide that it can only be quantified, or maybe weight, it can be quantified. It is a quantifiable metric, or speed, it is a quantifiable metric. Okay. So those are quantity. Okay. In our heart disease data set, we have a target label where we categorize people into do they have a heart disease or not have a heart disease, 0 or 1. Okay. So that is a category. Okay. If it is a category, then you need to see is your data labeled or it is unlabeled. Okay. What does labeled or unlabeled means? Label means that basically you have you already know what type of labeling you are expecting. In their target means that someone has heart disease or not have heart disease. But maybe there might be some data where you don't even know what that particular category is about. So it's basically completely unlabeled. Okay. It's very vague. So that can be unlabeled data. And then there are labeled data. In our scenario, it is labeled data. Do we have more than 100K samples or less than? So we have less than 100K samples. Is it a linear SVC? Not working. Yes, we are not sure. So, okay, cool. Go forward. Okay, is it a text data? No, yes, probably. Okay. And then what type of model then we can use? We can possibly use some sort of classifier model. There are so many different classifier model. Maybe we can use a classifier model from an ensemble stuff. This does not mean that we can't use Canon. We can use any of those, and we have to try it out. And we have to try it out. That's how we select a model. Okay. Now, cool. We loaded this. Okay, what is this X doing? What is this X doing? Someone explain me, what is this X doing? We have already done this data set. I've shown you this data set. At least with this data set, you should be familiar. What is this X doing? Hmm. Why are we deleting target category? Okay. X contains data features except the target label. What does this line mean? This is correct line, but what does this line mean? Why do we need to say target is a label and we need to drop it? And while you are saying that it contains other data features, what are the other data features and why it is like so? Again, answer me the why. I want to know why. Not moving forward unless I get an answer. So better do answer me on the chat or else I'll sleep. And we'll basically do nothing in this class. Tomorrow I'll do new topic. So even if it's a wrong answer, I want an answer. X contains, this statement is right, which is X contains the data features except the target label. I want to understand what does this mean here. Okay. X is containing, oops, 1 minute, I sent it elsewhere. Okay. So X is containing all the independent variables except Y, which is dependent variable. Yes, good, but it is cryptic definition. I want much more direct definition. Target is a dependent variable which depends on independent variables features. Now I still need a much more direct definition. What you guys are giving me is more sort of a Google sort of answer. This is not what I taught in the class. I am not saying that definition is wrong. I am saying what you are writing, you yourself don't understand it because that language is complex. We split the it into independent and dependent features. Independent features are used to predict the dependent variable or target variable. Cool. What are those independent variables? Uh, Whoever answered this last statement was actually sort of correct. Independent are used to predict the dependent variable or target variable. It is correct. X contains the data features except the target label. That's my answer. Any more answer? Direct answer. I mean, this is correct. We split it into independent and dependent features. Independent features are used to predict the dependent features. Okay. Obviously, we decide. Okay. So how we say it as like we actually split it into features and labels. Okay. What are the features? Everything is a feature except the thing that we actually want to predict. This is what I said in the class. That's why I'm asking easier definition. You guys are not giving easier definition, more sort of a copied definition. Okay. So label is the part that we actually want to predict, and everything else is the features on which we will base our prediction on. Okay. Which is correct. Everything else is independent, and obviously the one which is to be predicted will be dependent on the independent metrics. Okay. Hence, Y is our labels, X is our features. Cool. We then select our model, try to and initialize our model. Then we try to get params. What is this? This is basically getting all the default hyperparameters. Okay. Quickly answer, what is a hyperparameter? What is a hyperparameter? The default parameters which we can adjust or modify. It's right. Technically, it's right. The data that is used to manage machine learning model training. We set the value before training the model. Um, Basically, I mean, Avinash was sort of right what he said. It is, but not literally default parameters. It is basically uh, parameters which specifies the details of any model or the learning process. Okay. And this can be actually adjusted. Okay. Um, and this we tune it to actually get much more accurate predictions. Cool. Every model have different types of hyperparameters. That's something we need to know. That is why we are using this get params to understand, okay, what sort of hyperparameters at least this model has. You need to have some level of deeper understanding to manipulate a lot of these hyperparameters. Okay, but that will only come from some experience and Googling and using Chat GPT and so on and so forth. Okay. Um, okay. Then we test, train, test, and split data. We use model selection, so on and so forth. Okay. Now, why do we need to do this? Answer me, why do we need to do this train, test, split? for getting accuracy is right, but it is very short answer. I want a little more effort. The more we train data, the result better. Not really correct. Experimentation, not really correct. To split the data into training and testing data sets to train and test the model. But that does not answer the why. I want to know the why, not like what are we doing? Because we already know we are splitting it into test and train. Same, Ashok, you are just defining what we are doing. I want to know why we are doing what we are doing. To make predictions on unseen data. This is the closest answer. This is the good answer. Okay, but try to structure your answer in a much better sentence. Shiv. To evaluate the performance of the model. Not really true, at least at this stage. Shiv's answer is actually correct, but it needs to be structured more. All of you guys are having some Gajini issues, short-term memory loss. We repeated this process so many times. Sriya, I already said Shiv's answer is correct. I don't know why you are making this statement because that is incorrect. Okay. So let me tell you and structure it for you. Basically, we are splitting into 80-20 sort of percentage. Why are we splitting it? One, we need to have a training data set. Second, we need to have a testing data set. This training data set should, usually it is a 80-20 split or 70-30 split where like 17-15, 70-15-15, where 15 is validation, 15 is testing, and 70 is training. The data which you train on should not be the same as the data which you test on, because you want to test the prediction of the data that has never been seen, so as to know that if your model is working as you expect it to work. That is why we split the data. If you try to actually run your model on the same data that you are training it on, you will get 100% results, which is not possible. There has to always be some sort of error rate in your result. Okay. Now, CLF fit comes from the model itself. It's an inbuilt function. We basically fit in our training model and train it. Okay, build a forest of trees from training set XY. That's what it is saying. Okay, then what are we doing? We are basically making predictions. 1 0 1 1 1 1 1 1. Okay, it looks cryptic as of now. Okay, but this is basically prediction on our test data set. This is basically prediction on our test data set. But if you remember here, when we are splitting, we are getting Y test and X test. X test is what? Is our features. Y test is what? Is our label. Okay. But if you see here, we took in X test and basically predicted label, which is Y. We already predicted label. Okay. Hence, why we need Y test is to get the score out of it. So for example, what happens if you train and test on the same data? For example, see here, X train and Y train. What do we get? The score. We get 100%, which is not possible. It is not practical. When we do X test and Y test, now we got something here and we are now checking it against Y test. We are getting 81%. Okay. Try to understand it. I give you 5 minutes break. Prepare some questions. I'll be back. Okay. No questions. Nothing. Everyone is intelligent. Cool. Okay. I'm visible, right? I'm visible. Guys, I'm visible. I'm visible. Answer yes, no. Cool. Okay. Okay, so you get 81% prediction. Okay. On your test label. Now, we can generate some reports out of it. Now start telling me what is a confusion matrix? Ideas, confusion matrix. To evaluate the accuracy of a classification. Okay. Okay, let's see. Predictions made by the model and compares them to the actual outcomes. It displays the number of true positives, true negative, false positive, false negatives. Yeah, that is the correct answer. Sai Ram, correct. Yeah, you are super intelligent, Sai Ram. Very good. Cool. So we get some classification report, and then classification report gives us these 4 parameters on which we need to analyze: precision, recall, F1 score, support. We discussed this. What is precision? Precision is what percent of your prediction is correct. Recall, what percentage of the positive cases did you catch? F1 score, what percentage of positive predictions were correct? And support is number of actual occurrences of the class in the specified data set. Okay. Now, how can you improve your model? So there are several ways. What we can do is we can try to change some sort of hyperparameter. In this particular example, what we were trying to do is like change hyperparameters from which is this estimator hyperparameter from 10 to 100. Okay. stepping on every 10 elements. So it's like 10, 20, 30, 40. And then we got some values, and we see that when the hyperparameter was like somewhere around 70, we got the highest level of accuracy. Okay. Now you see confusion matrix. What confusion matrix tells us that we had 21 true positives, 5 false negative, 6 false positive, 29 true negative. Okay. True positive means the prediction was true and you also predicted it true. Okay. False negative means the prediction was false and you also predicted it false. False positive means the prediction was false, but actually it was true. True negative means it was actually false, but you predicted it true, and so on and so forth. Okay. Hey, did I say it wrong? Wait, I said it wrong. True negative means it made correct 29 predictions of false, and it made correct 21 predictions of true. True positive means correct true predictions, and true negative means correct false predictions. False negative is correct false predictions. False positive means sorry, incorrect false predictions, and false positive means incorrect true predictions. Okay. Sorry, it's so many false positive, negative, negative, positive that I also say it wrong. Okay. Then we can directly use inbuilt function accuracy score to get the accuracy out of it. We can use pickle to actually save. And then I also showed you another library called as joblib, from which we can save our model directly and we can reuse that model again and again. Okay. Now, what does cross-val score do? Why do we need cross-val score? Answer. Why do we need cross-val score? Used to evaluate a machine learning model using cross-validation. That I also know. I can see it. You are just repeating. What is accuracy? Used to evaluate machine learning model. What is confusion matrix? Used to evaluate machine learning model. Everything answer is used to evaluate machine learning model. Why? To prevent overfitting. Answer is just directly on your screen, to be honest, if you look at the screen properly. No. Okay, I'll tell you the answer because it's already on the screen and you guys are finding it hard to read the screen. What is it? Measure the mean cross-validation score across 5 different training and test splits. This means that having, let's just say if you have one data set, but you can actually split the same data set into different types of combination. In here, in this scenario, because we set CV equals to 5, we are making 5 different combination of test data sets and testing data set. And we are doing so to actually get the highest number of accuracy, because the data might have different types of parameters, redundancy, and so on and so forth. So it might result in different level of accuracy. That is why we need this cross validation score. If you see, this is done. Initially, we were doing this manually, 10, 20, so on and so forth. Now we are doing this with CV, changing the model pattern, and we get accuracy score also differently when we are providing it with some different type of data split plus estimator. Okay. If you see in here with 5-fold cross validation score, we get the highest at 83.49, which is at estimator 120. Okay. Now this whole process, what we just did, can be automated with what? With grid search CV, which is already provided by scikit-learn. All we have to do is create a grid. Okay. What do we do in this grid? We basically create a grid of hyperparameter. In this case, we are making it of an estimator, and we are making a range of an estimator from 10 to 500, stepped over 10 on each iteration. Okay. We pass param grid here, estimator. Basically, we are saying that, okay, use this random forest classifier model. Cross validation, we say that, okay, again, use 5 different cross validation split. Okay, make it verbose. And then we do same grade fit X and Y. Where are we getting this X and Y from? Where are we getting this X and Y from? We are getting this X and Y from here itself. Okay, we are getting this X and Y from here itself. Okay. Okay. Now we do this, and then it says fitting 5 folds for each of 49 candidates, totaling 245 fits. Now basically it's performing a lot of iterations to get you the right and most accurate testing training data to get the most accurate result out of it. Okay. It says the best parameter values are where an estimator is 200. Okay. So that's what it said. Now we say that, okay, initialize the model, the initialize classifier model using the best estimator now. Now we have the best estimator. We try to repeat the same process, fitting the training model, okay, and then testing out of it. And now what we get is 85.25% of accuracy based on split data, which is much better than our previous 81% accuracy, if you remember. Now I said that we can save this model into 2 ways. One is using pickle, another is using joblib. Pretty simple. No science involved. Okay. Now, always split the data into features, usually X, labels, usually Y. You now already know what is features, you already know what is Y, labels. Split the data into training and testing data set, you already know what are these, and possibly a validation data set as well. Okay. It is basically another layer of checking that your predictions are correct or not. Okay. Filling, or also called imputing or disregarding missing values. We didn't look into missing values yet. We'll look into missing values. We have covered this already in our previous classes. This is basically just a recap of that. Okay. Converting non-numerical values into numerical values. Okay. We have this new data set of car sales extended. It has 1,000 data points. We have also seen this particular data set. Okay. Okay. Now we are getting these data types. Answer me, why do we need all these data types and data frames? Why do we need to get these data types, data frames? Data analysis, correct. Why do we need to do data analysis? Why do we need to do data analysis? To select the right model. Still answering vague. Man, just like 15 minutes ago, I told you this answer. Pay attention, guys. Pay attention. We are doing all this data analysis to select right model. Wrath God said it right. But sadly, he is replying me all on direct message. That's why you guys can't see it. Don't DM. Yeah, I already answered, Dilip. To select the right model. To select the right model. Okay. It says in Telugu, Saraina Modelini Enkuko Vadaniki. I don't know if I said it right, but that's what it says. I hope you understand it now. Okay. So we are doing this data analysis to select the right model. Right, Rath God? Now you have this training and split data. Why are we training and splitting? Why are we splitting this data? And what is this 0.2? Answer me. Right, 20% of whole data test size, correct. To predict the unseen data properly, we split the data, correct. Correct. Then we repeat the same process. Okay. And if you look at here, what are we using? We are using random forest regressor. Why are we using regressor? Answer me this. Why are we using regressor? Answer me this here. Why are we using regressor model? Answer me this here. Why are we using regressor model? price is a quantity. Correct. Price is a quantity. That is the correct answer, friend. Price here is the quantity that we need to predict. And when we split our data into features and label, we see that we are setting our label as price, which is a quantity, and everything else is a feature. Okay. And if we want to make predictions on a quantity, then we need to have what? We need to use regressor. Based on what? Based on our cheat sheet here. Quantity, predicting a quantity means regression. Okay. We try to fit in this data, but we get this error. Why are we getting this error? Tell me fast. Look here, why are we getting that error when we try to fit in? Tell me fast. That is wrong. It doesn't matter if the features have categorical data or it does not have categorical data. It does not matter. Again, the answer is in your on your screen already. Exactly. Exactly. All the data types must be numerical. It won't work on object type because we can only make predictions on numerical type, which it is not, as you can see here. Hence why we do data analysis to actually avoid these sort of issues as well. Right? We did data analysis. We know that some places we have objects. Hence, what can we do? We will eventually need to convert these objects into numerical data. Okay. This numerical data should be something like this that we can do. Make some sort of confusion matrix out of it. Okay. There was a method we talked about, one hot encoder, which is one of the simplest way to actually convert objects into some sort of encoded numbers. Okay. We can make or divide in it into different sort of categorical features. Okay. To base our predictions on. Then we use column transformer and so on and so forth. And finally, we get numbers of all those categorical features, make, color, and door. Correct. If you remember that I said we are converting only objects, but door is numerical. I answered this in my last class. Why am I also including and transforming doors? Someone tell me that. Answer me. Correct. Because the value of doors can be categorized as well. 3, 4, or 5. That is why we are categorizing door. Okay. Now, we can also use pandas out of the box to make these predictions, and you get this true, false, true, false. And if you see, for all these categories, it tries to make those predictions. Okay. But on doors, it does not do it automatically. Hence, doors first needs to be converted into object. And then it is converted into, it is basically encoded into one hot encoder. That's one way to use pandas.getDummies to get all these values. And then we can actually make prediction on all of it, because now everything is converted into numerical form. Right? What if there are missing values? We had another set of data where we had missing values. There are two possible approaches. One, either you fill them with some given calculated value, which is, this whole process is called what? Imputation. Or you remove that completely. Okay. We get how many values are missing. Is NA is a function which gives us the number of missing values. So we see make, color, odometer, doors, and so on and so forth. Roughly each of them have missing 50 sort of values. Okay. So first we create number of features set. Okay. For the missing data set, which already contains missing values. Okay. Then we try to convert the categorical column into one hot encoded, okay, stuff. We are pretty much doing the same process what we did above. Sorry. But in here, we are directly using one hot encoder from scikit-learn, column transformer from scikit-learn, and we didn't need to do anything pandas related. So we got it directly out of scikit-learn. Okay. So we got this. Then we are splitting data. But if you split data and try to fit and score, it does not yield any result. And why is it not yielding any result? Because Y contains NaN. Because it has missing values. Okay. If we try to use those models which can handle NaN values, like his gradient boosting regressor, okay, then also we get some sort of weird errors. Y contains NaN. Thus far, we can't make predictions with missing values and we need to fix it. So there are few options that we have. One, which we said imputation. So we do fill NA and we do imputation. And what we are doing is we are marking all of those places, okay, all of those places which has NaN and adding in missing as default value. If you see, make and color is now 0, 0 missing values. Okay. Now for the doors, because it is a value, what we are doing, we are taking out the most common value. For example, in here, most common is 4. There are maximum amount of 4 doors. That is why the error rate would be small if we actually commonize all those missing values. Hence, we are inputting 4 doors for all the missing places. Now you see when doors are 0. Then what comes? Odometer. Now odometer has a value which is quite variable. Okay. It is quite variable and it is quantifiable. Hence, what we do, we take out mean and then replace it with mean. Okay. Finally, what do we have? We have price. Okay. Now, price is because price is label values, missing values. We would rather not even predict those missing values because it is unlabeled. We will directly omit that from our model and hence we drop it. And that's how we prepare our data set into a model that can be predicted. Then we use the same process using a one-hot encoder from scikit-learn and column transformer from scikit-learn to make these predictions. Do note, I already showed you doing the same thing with pandas and also manually, but technically it's just easier to use it from scikit-learn itself. It already provides these things out of the box. Cool. Then we try to use our random forest model, try to repeat the same thing, model fitting, scoring, and now we get some prediction. Okay. Cool. We try to do the same thing. We try to get the extended missing data. We have these values is NA, we drop NA. Okay. From the missing data, we have now these many missing values. Okay. Because we already know at least where price is missing, we don't want to predict it. Finally, now what we are doing, we are splitting it. Now we have split the data into train and test sets. Here, first to perform filling missing values on them separately. This is best practice as the test data is supposed to emulate data the model has never seen before. This is what I have been saying already. For categorical variables, it's generally okay to fill values across the whole data set. However, for numerical values, you should only fill values on the test set that have computed from the training set. Okay. Hence why we omitted the data which we don't really need. Now, we were also imputing manually, but scikit-learn also provides imputer out of the box. We can just use simple imputer and it does it for us. And we can define how we want to impute it. There are several strategies. Like earlier, we are using a constant value missing. For what strategy? For door, we are using 4 as constant. For odometer, we are using mean and so on and so forth. Okay. Doing pretty much the same thing, we get imputer. Okay. What we do, learn the imputation values from the training set, fill the missing values in the training set with the values learned in step 1, and then fill the missing values in the testing set with the values learned in step 1. Okay. Finally, what we are doing, same thing, filling and transforming the data. Cool. We are again filling and transforming the test data. And here we can see how it has been filled and transformed. Okay. Now, when you actually get the data frame and everything out of it, we'll see we don't have any missing values anymore. Okay. Since we don't have any missing values anymore, while in the original data set we had this missing values, we can actually perform our operations on the filled data set again. But before that, we need to again transform it and encode it, turn it into numerical values so that we can make predictions. We are making predictions. Cool. And finally, we use regression and we made predictions. Okay. This is pretty much the same process that we will be following over and over and over and over. Okay. Same process that we need to follow. How do we choose the right model? I have showed you this chart again and again already. We choose the right model based on what sort of data we have. We have done this over and over. So I'm just skipping this part. Okay. Okay, what is predict and what is predict proba? I already explained it. Answer me fast. What is this and what is this? Predict and predict proba. No one is interested in answering. Not even wrong answer. Correct. Predict proba is the probability of the correct predictions. And what is predict? So predict is used to predict the actual category or class or label. Okay. And predict proba is basically probability of the prediction. Okay. Of each of those category. That is what it is. Not a super rocket science. We are repeating the same process here, same process here. There's nothing different that we are doing, splitting data, splitting it into features and labels, then basically testing it and so on and so on. Okay. Same here. We make predictions. Okay. We try to get mean, absolute. So compare the prediction to the truth value and we try to get. So there are several other metrics that you can actually get around it. This is what here. This is how splitting works. I showed you. Okay. When I was talking about cross validation, this is how it works. You see different sort of data set, it is working around. Okay. Now, classification model evaluation metrics. There are four main evaluation metrics methods. Okay. Accuracy, area under ROC curve. Okay. Which is receiver operating characteristic curve. Confusion metrics or classification report. Same process. Okay. Now, what is AU ROC? Area under is basically omitted. What is ROC? Okay. I don't know how to write assignments. Probably via notebook. However, Blackbucks is actually doing. Okay. So ROC curve. It's usually referred to as AUC for area under curve. And the curve they are talking about is receiver operating characteristics or ROC for short. So if you hear someone talking about AUC or ROC, they are talking about this, okay, which is the comparison between true positives and false positive, which is comparison between your confusion metrics. So see here, true positive model predicts 1 when truth is 1. False positive model predicts 1 when truth is 0. True negative model predicts 0, okay, when truth is 0. False negative model predicts 0 when truth is 1. This is what your ROC curve is. We get ROC curve directly from scikit-learn library. We can get it. Okay. This is how the plot looks like. This is a very correct sort of plot because it should never be straight line like this. This means that this is a perfect graph. This is the perfect graph. Okay. This means that, okay, it has some sort of error value, which is natural. Okay. So in here, AUC is 0.93. There. Okay. We looked into this confusion matrix display as well. Same thing, true positive, false positive. Okay, we have defined here all those um, different sort of metrics based on which you actually experiment with your model. Okay, there I have already discussed most of it. You can read again for more details. Now for regression model, we use some different type of metrics, which is uh, R squared or coefficient of determination. Okay. Okay, sorry. R coefficient, mean absolute error and mean squared error. Okay. Um, a lot of maths in here, but all you need to understand basically it gets the it is basically mean between the predictions. That is what R coefficient is. Okay. Uh, Higher is much better. Mean absolute error. Okay. The average of the absolute difference between predictions and actual values. Cool. Difference between prediction and actual value. That is what you are getting here. Lower is better. That means you have lower error rate. Mean squared error. The error average squared difference between predictions and actual values. Again, lower is better. So anything error related, lower is better. Okay. You can get all of these metrics using scikit-learn. For example, R2 score, we can get it here. Okay. Mean absolute error, 0.327 and so on and so forth. Okay. We can plot it to get much more detailed analysis out of it. Same here, MSC, mean squared error from scikit-learn. So it all works. Now we are doing the same thing, same cross validation, same everything. Okay. To get the best possible result out of all of this. Okay. We try to get cross validation score for our random forest classifier in here, our housing also, we try to get cross validation score, and we try to select the best model just like what we tried to do in our classifier model. This is what we are doing, pretty much the same thing. This is nothing new that we are doing. We are doing the same thing here that we have been doing, trying to calculate the evaluation metrics. This is for classifier. This is for regression. Okay. And based on this, we can actually improvise our model. Cool. Now, in this whole process, we have technically done split like 80-20, but you can do split as such with validation split, and where in validation split, you will try to tune in hyperparameters and then finally test on the tuned data set. Okay. So we can also use randomized search CV, like we have earlier used grid search CV to make these hyperparameter tuning. We can also use randomized search CV. It works very in a similar fashion as grid search CV. We basically give it hyperparameters that we want to tune in and so on and so forth. Works pretty much the same, runs for a longer period of time. If you see, it works on a lot of different combinations and finally give us some best value out of it. Okay. So there, if you see, grid search CV is still having the highest possible prediction accuracy. That's why it's just a standard. You can use grid search CV instead of randomized search CV, which I have already shown. This notebook is already shared to you. Okay. Hence, here on, you can actually practice with it. That's the end of recap of scikit-learn. There is nothing new in it. Now, if you have any questions, you can basically ask me, but I have pretty much covered all the concepts that we did on our scikit-learn class. That concludes our recap, and in the next class, we will be working on deep learning. Anyone has any questions, you can ask me now. Probably 1 to 2 class. I'll rush it. Would be done before that. That's why I said 1 to 2 class. But if you have good understanding of scikit-learn, it should be easier for you to get adopted to deep learning as well. Eventually, that is also just using a library, particularly PyTorch and TensorFlow. That's what we use and make predictions. It's just that you need to keep the frameworks of doing things in your mind. None of you have any questions? No, not in deep. Neural network is not covered in deep. because neural network in itself is a whole block of course which takes a lot of time. So I mean, I'll go through it, but not in extensive detail. Yes, probably seventh is the last, right? So yes. There's so many options, Teja. Just go into Kaggle. I'm pretty sure you will get a lot of stuffs out of there. For scikit-learn, I think so the best project that I can recommend is predicting insurance claim. And I have seen data set around it on Kaggle already. It is a very interesting project and a very generic use case. A lot of insurance company actually use that. So you can actually try to make those predictions. Sadly, you won't be able to make predictions on Indian insurance market because Indian companies do not expose a lot of insurance data. One good one from for probably for your deep learning project, you can try to do some background remover sort of AI background remover. You see a lot of images and you want to remove background from that. Maybe you can try that. So that is one good one for unstructured. A few things you need to keep in mind. See, R square is very similar to accuracy, okay? It sort of gives you a quick indication of how well your model might be doing. Generally, the closer your R square is, it is much more accurate, okay? MA is mostly a better indication of how far off each of your model predictions are. And MAE or MSE, because of the way MSE is calculated, is squaring the difference between predicted values and actual values. It amplifies larger differences. So let's say we are predicting the value of houses, okay, which we have been doing. You will pay more attention to MAE when being, for example, $10,000 off is twice as bad as being $5,000 off. Okay. So the error rate is something that you need to also understand how it's calculated and so on and so forth. How much time it will take to learn AI and ML completely. Depends on your practice, man. See, all anyone can do is only teach you the outline of things. How you take it from there is in your hands. cases in any type of programming, you are a lifelong learner. If you ask me how long will it take you to become better, maybe develop at least 3 to 4 complex projects. Try to give at least 2 hours every day into programming. Try to make Git